Hey guys, Miss Davis here. You are now watching Unit 2, Skill 5, Even and Odd Functions. So pause the video, write down your essential question. How can we tell if a function is even or odd? And we're going to be looking at the graphs of different functions and being able to tell if they're even, odd, or neither, technically. So let's go ahead and after we have that written down, let's start reading. So it says, knowing whether a function is even or odd helps you graph the function because the information tells you which half of the points you have to graph. These types of graphs are called symmetrical. So whatever is on one side is exactly the same on the other side. So if a function is even, it is symmetrical about the y-axis. Okay, so that symmetrical just means it has that mirror image, and I believe this is later in the notes, but it has a mirror image on either side of the y-axis. Okay, then a function is odd if it is symmetrical about the origin. So symmetrical about the origin is the same thing as a rotation of 180 degrees. Okay, so these are some big key ideas here. You want to star these two. Even is symmetrical about the y-axis, and odd is symmetrical about the origin or a rotation of 180 degrees. Okay, so let's keep on reading here. An even function. The mathematical definition of an even function is f negative x, which means you're reflecting over the y-axis. Because it's affecting the x's, it's just changing all your negative x's to positive and all your positive x's to negative, and it makes that mirror image. So in looking at a very basic equation, f of x equals x squared as an example, because f of x equals negative, f of x negative for all x. So for example, when you plug in a positive 3, you get 9, and when you plug in a negative 3, you also get 9 because 3 squared is positive 9 and negative 3 squared, oopsies, I'm writing 3's, 3 squared and negative 3 squared equal that positive 9. So basically you're getting the same output when you plug in the positive and negative version of the same x value. So for instance, if I look at negative 3 in the table, so here's our parabola, that's that x squared equation, so f of x equals x squared, and it's that basic parabola that starts on the origin, and if you look at the negative 3 value, negative 3 up 9 right here, if you look at its mirror image of positive 3 down here, has the same output, so 9 for both of them. So there's that symmetrical on either side of the y-axis. So if I highlight the y-axis, it's the same number of units away from the y-axis as the other side. So this one here is 3 units away from the y-axis, and its mirror image is 3 units away as well. So, and if we can keep looking, you can see that the points are symmetrical in the table too. So we've got 1, 1, 4, 4, 9, 9, and then our center of that symmetry there is that bottom of the parabola, or the minimum, 0, 0. Okay, so that represents an even function because it's symmetrical about the y-axis. Now an odd function has the definition of f of negative x is equal to negative f of x for any values of x. So the opposite input gives you the opposite output. Okay, so that just means that if you have a point xy, if it's rotated 180 degrees about the origin, or if it's symmetrical about the origin, then you get negative x, negative y, or you just negate the signs. So if they were both positive, now they're both negative, they're both negative, they're both positive, and so forth. So for example, our example here at the bottom is f of x equals x to the third power. So a cube function is an odd function because if you plug in f to the f of 3, when we cube 3, we get 27, and when we cube negative 3, we get negative 27. So negative 3 times negative 3 times negative 3 is a negative 27, because negative times a negative would give us that positive 9, but then we multiply by a negative would give us back a negative 27. So if you look in your table first, see how we had negative 27 negative 3 and negative 27. If you look at its match, positive 3 and positive 27. So there's that idea that if I had both negative, now I'm going to come out with both positive. Okay, and that's only true when you're rotating 180 degrees around the origin. So same thing, negative 2, negative 8, positive 2, positive 8, and so forth. So there's still symmetry, it's just not around the y-axis. So and if we look at the graph, they have 180-degree symmetry about the origin. So if you turn the graph upside down, it looks exactly the same. So see, this point right here is the same number of units over and down, and then you would just go over and down, same number of units from the center of rotation, which is that origin. Then this point out here has the same number of units over and up. If I were to go up and over, and then down and over, it's the same number of units away from the origin. So that's 180-degree rotation about the origin. Okay? So we have to be able to tell just by looking at the graphs if it's odd or even and be able to explain. So that's what our next page is going to look like. So flip over. Okay, so I just kind of rewrote the big ideas from the last page, just because this is new to you guys. So if it's an even function, it's symmetric about the y-axis, and if it's odd, it's symmetric about the origin. So we have to state whether the graphs are even, so even ones are around the y-axis. Odd, so odd is about the origin, or neither, which means that there's no symmetry around either of those two things at all. Okay, so the first one, number one, if you can look at, I know there's no numbers on this graph, but do you see how if I drew a line on the y-axis, then this function should be the same on either side, and is symmetrical as a mirror image about that y-axis. So this one would be even because symmetrical about the y-axis. Okay, got that mirror image. Number two over here, if you look at the way, it looks like an M here. So if I highlighted the y-axis, does it look like those points are evenly balanced on either side of the y-axis? Yeah, so it looks like those top 2 points are the same distance away. And if I were to like identify 2 more spots, then it definitely looks like it has that mirror image or that reflection over the y-axis. So it would be another even function because symmetric about the y-axis again. Okay, so the next one here, number 3, we want to check. It doesn't look like either, but let's just check. Is it symmetrical about the y-axis? Are those points reflecting or mirroring themselves over the y-axis? No, it's not. And then we have to check to see if it's odd, meaning do these points match up if I were to go, let's see, let me erase that point. If I went over and up to that point, if I went over and down to that point over there, do they match up on that graph? No, so this graph right here is neither because not symmetric around or about the y-axis or origin. Okay, that should be a y there, y-axis. Okay, number 4, we are looking at it and maybe you're like, it's definitely not symmetrical about the y-axis because it's definitely not being mirrored over the y-axis. But we need to check to see if it is symmetrical about the origin. So if I look, I see on the left side it kind of goes down, up, and then back down. So I'm going to erase that because that's ugly. But if you look at this point at the top, it looks like it's about the same number of units over there. And if I were to go from the origin over and down to this point, does it look like if I went left and up to that point that it would match up? The answer is yes. So these points are actually being rotated 180 degrees, either left or right, depending on which way you look at it, counterclockwise or clockwise, about the origin. So this is an odd function because it is symmetrical about the origin. Okay, so all those points are being rotated about the origin. They're the same distance away from that origin. Okay, moving on down here, why don't you guys try number 5 and 6? So go ahead and pause the video and try 5 and 6 on your own. Okay, so number 5 is definitely even because it is symmetric or has that mirror image about the y-axis. And then number 6 is odd because it is symmetric about the origin or the points have been rotated 180 degrees and so forth. Another way to check if it's rotation of 180 degrees is do those points move 2 quadrants to the left or to the right. So if they shift over 2 different quadrants and end up 2 quadrants away and the same distance from the origin, then that's a rotation of 180 degrees about the origin. Okay, so go ahead and answer the summary questions at the bottom and try all of your practice.